You know, for most of human history, the biggest killers on the planet were completely invisible. They'd strike without any warning, and for centuries, nobody knew where they came from or how to fight them. This, right here, is the detective story of how we finally unmasked them.
So the central question was really simple, but the answer? Anything but. Was it bad air? An imbalance of the body's humors? Maybe something else entirely? For literally thousands of years, we were all just guessing in the dark, and millions of lives were hanging in the balance.
You know, the first real break in the case didn't come from some famous doctor or a well-known scholar. Nope, it came from a man who sold cloth. A guy with an incredibly powerful magnifying glass and a curiosity that just wouldn't quit.
Okay, so our investigation kicks off in the 17th century. We are on the hunt for our very first person of interest. And the trail, it starts with finding our first suspects.
And this wasn't just any microscope. Leeuwenhoek's homemade lenses were so incredibly powerful, they literally opened up a dimension no one even knew existed. And the funny thing is, he wasn't even looking for the cause of disease. He was just looking at, well, everything. And what he found was, well, it was mind-blowing. He called them animalcules, these tiny little animals. And they were everywhere, in rainwater, on his tongue, swarming in the plaque from his own teeth. What's so fascinating is he even ran these little experiments, like he noticed that drinking hot coffee made them all disappear. But the most crucial clue was this: he always consistently found these creatures wherever there was sickness and rot.
And that single observation sparked a debate that would rage for nearly 200 years. It was the ultimate chicken and egg question, right? Were these microbes the murderers, or were they just scavengers showing up after the crime had already been committed?
This whole question led to a huge scientific standoff. It went on for nearly 2 centuries, and honestly, the answer was going to determine the entire future of medicine.
So on one side, you had spontaneous generation. This was this ancient idea that life can just, poof, appear from nothing. And you could see why people believed it. It's what they saw every day. You leave out some meat, and suddenly there are maggots. It looks like they were born from it. But on the other side was biogenesis, the idea that life only comes from other life. Its supporters argued that no, those microbes weren't being born from the decay, they were just traveling through the air and landing on it.
This stalemate, it really needed a brilliant detective to just come in and break it wide open. And that detective, his name was Louis Pasteur. Now, Pasteur's investigation didn't start with human disease. It actually started with a problem that was bugging French winemakers. Their wine kept going sour. At the time, most chemists just thought fermentation was a simple chemical reaction. But Pasteur, he proved them all wrong. He showed it was caused by tiny living things. And here it is. This is the breakthrough. Pasteur realized it wasn't just some random swarm of animalcules. He proved that specific microbes had specific effects. The nice, round yeast cells, they made good wine. But these other, long, rod-shaped microbes? They were the culprits, producing lactic acid and totally ruining the batch. This was the crucial link everyone had been missing. One type of germ leads to one specific outcome.
So armed with this knowledge, Pasteur designed one of the most brilliant, most elegant experiments in all of scientific history to settle this debate once and for all. Here's what he did. He boiled broth in these special flasks to sterilize it. The S-shaped neck let air in, that was important, but gravity trapped all the airborne dust and the microbes clinging to it right there in the first bend. And guess what? The broth stayed perfectly clear, indefinitely. But the moment he tilted the flask, just enough to let that trapped dust touch the broth, it just exploded with life and rotted.
The verdict was in. Life did not just spontaneously appear from the broth. It came from the microbes carried on dust in the air. The case against spontaneous generation was officially closed.
So, Pasteur had proven that microbes were the culprits. But now, medicine needed a way to convict a specific microbe for a specific crime. And that's where Robert Koch comes in. He basically wrote the rule book for how to do it.
See, Koch was a master investigator, and he seriously upgraded the team's equipment. He used a way more powerful microscope to see even smaller suspects. He used special dyes to make different bacteria stand out from each other. And, this is so important, he used a solid gel to grow pure colonies of just a single type of bacteria, isolating it from all the others.
His target was one of the biggest killers of the 19th century, a disease they called the White Plague, tuberculosis.
Using his brand new methods, he was actually able to see and isolate the tiny, rod-shaped bacterium that no one else had ever been able to find, the tubercle bacillus.
But just finding the bacterium? That wasn't good enough for Koch. He needed to prove its guilt beyond any shadow of a doubt. So he established these 4 rules, which we now know as Koch's postulates. You can think of it like the scientific version of finding the suspect at every crime scene, getting them alone, proving they can commit the crime again, and then identifying them again after they've done it. It was a completely bulletproof method for linking a specific germ to a specific disease.
So, with Pasteur's theory and Koch's methods, the floodgates just blew wide open. The age of medical bacteriology had officially begun.
The central mystery was solved. Disease wasn't caused by bad air or some mysterious force. No, it was caused by microscopic invaders. For the first time, humanity finally knew its enemy.
And just look at what happened next. Using Koch's rules, scientists started identifying the culprits behind humanity's oldest enemies, just one after another after another. Gonorrhea, tuberculosis, cholera, tetanus, the plague. The dominoes just fell with this breathtaking speed. It was a total explosion of discovery.
And this, right here, is the most important takeaway of all. The germ theory didn't just explain disease, it gave us a playbook to actually fight back. For the very first time, medicine wasn't just guesswork and superstition anymore. It became a science. Because if you know your enemy, if you can see it and isolate it and understand it, then you can finally figure out a strategy to defeat.
And the impact was immediate. Pasteur used his knowledge to develop vaccines for deadly diseases like anthrax and rabies, saving countless lives. Koch's methods of isolating bacteria became the foundation for developing targeted treatments and, eventually, antibiotics.
When you boil it all down, this entire medical revolution was built on this one simple but incredibly powerful idea. It's a concept we totally take for granted every single time we wash our hands or get a shot, but it was forged through centuries of brilliant detective work. Pasteur and Koch, they identified the enemy and they wrote the first playbook. But here's the thing, the enemy evolves. In our modern fight against emerging viruses and antibiotic-resistant superbugs, we're constantly being forced to write new chapters in that book. The great detective story? It continues.